Welcome back, everybody, to the Sci-Cast. We are now at episode 20 already. Can you believe it? It's been months.
It's been almost a year. Over a year. It's
No,
been over a year.
No.
Yeah.
No. October, I think, is when we started.
Really?
Last year.
Holy crap. Okay.
Anyways, that's a long time.
Yes. For me, exactly. No.
Really? It's a lot of driving time. So, what are you trying to interrupt me?
Yes,
I'm trying to start this thing.
Okay, start it. God.
Okay. Here we're on episode 20 of the Sci-Cast. We're going to do it on the hypersonic glider from DARPA. And we were going to do originally on quantum mechanics, but some special guests couldn't make it today.
And then we were to do cryogenics, but then another special guest wanted to do that, so...
He can't make it.
And he can't make it.
So we made up this one in a couple minutes.
Yeah. So, bear with us.
So, I am Dr. J, your host.
I'm Heyman.
And, well, if you don't know what DARPA is, that's the Defense Advanced Projects Research Agency. Yeah, it is.
It's Defense Advanced Research Projects Agency. You said Project Research Agency.
No.
So.
Sorry, I have dyslexia.
I just wanted to make sure you said it right.
You're telling me.
I didn't want.
I had to say it right.
I didn't want DARPA to come after us.
Okay.
They would send a ship to us. Anyway, yeah.
Probably a hypersonic glider.
And just destroy us.
So, what is a hypersonic glider? Heyman?
Okay.
It's a really fast projectile.
Yes, it's extremely fast. We know what supersonic is. Well, hypersonic is actually above that.
Well, yeah, hyper is better than super.
Any which ways. So it's 13,000 miles per hour.
Just think about that.
That reaches from one pole to the next, halfway around the world in 1 hour. So basically, DARPA wants to make it so they can deliver a payload to any place on the world in about an hour, which is extremely nice if we wanted to kill everyone.
Sometimes we feel like that, don't we?
Yes. So, imagine being able to bring a payload of nuclear explosions to any part of the world in 1 hour.
So now you agree with me.
I'm just saying, it could happen.
Because not only is this projectile, if you were to hit something at this speed, it'd still make a pretty good crater.
Yeah.
So I said, well, why don't you put a bomb on it, make a bigger crater?
Well, no, they actually said it on the paper that it was for.
I didn't read that.
Yeah, it's believed to carry high yield explosives.
Well, we don't want low yield in the American military.
No.
Not good enough. Same reason I don't take Tylenol with
codeine.
What do they call it?
Tylenol.
Maximum.
Maximum.
Tylenol. You don't want the minimum Tylenol. You want
so,
maximum.
yeah, it says create aircraft to potentially deliver bombs to any part of the world in less than an hour.
Which means that those commies think they can start doing stuff. They better watch themselves.
Yeah. So, imagine this: from California to Tokyo, it is 5,500 miles distance approximately.
It's like you knew that.
Yes, we looked it up.
Yeah, we did.
So approximately.
We did research before this.
Yes. Normally we do.
Right. We'd always research.
Normally I do.
Because I already know this.
So, from Tokyo to California, it's approximately 5,500 miles distance. So that means
a boring plane ride, that's what you're saying.
Yes, a very boring plane ride. So in about half an hour, we could basically annihilate Japan.
We're not picking on Japan just because we hate them.
No, I ain't. I like Japan. They have a lot of hot girls.
It just happened to be the one we thought of first.
Yeah. I guess we could look up the distance between here and Korea.
North Korea specifically.
Yeah.
It's probably only a few hundred miles more.
Yeah.
They're right next to each other.
From USA.
The power of Google.
To
North Korea.
North. Yeah, you can type the rest.
Korea.
No, we don't want relationships.
Oh, here, yeah, do that.
Distance. Between nothing. There we go. That's good enough. So the distance is approximately 4,000 miles. So, yeah, we could bomb them in 30 minutes easily.
But that one says 6,000.
Okay, still, from 40 to 30,000, from 4 to 6,000.
Right.
So
that's a pretty big jump.
No, but it's still anywhere about a half an hour.
Anyway, this thing can hit it
in about a half an hour. Okay, so
think of it this way. What was that from? New York, you said, or USA?
Well, that's just
Thinking
from
if you
USA.
launched it from
Oh no, that's California and North Korea to Washington.
Okay, that makes sense. Okay.
So.
Well, think of it if we launched it from Hawaii. Bam! 15 minutes, you're gone.
Hawaii is actually. No.
That's close.
I don't know. I couldn't really say.
Well, I know it is south and southern, but it's even still, it's probably closer.
Well, California.
Or Alaska. It
says from Alaska right there. So I was curious how far we would have to reach the destination I mentioned. Has a missile that can go about 4,000, so about Alaska. So from North Korea to Alaska, it's 4,000 miles.
How about we launch it from Japan? We're friends with them.
Well, I'm just saying, though.
Or South Korea.
But would you like them to have our technology?
No.
Okay.
That's why you got to show a bomb to them. Destroy the thing.
So, anyway, Troy,
it's a spontaneous crater that just happened to come up in your...
well, yeah, we were...
Meteorite.
We were looking at that, and if we dropped one of these straight down on top of a civilization...
90-degree angle.
90-degree, straight down, and density of 10,000 kilometers per second, I think. Kilograms per what? Something.
It was kilograms...
Well... About the density volume, maybe a little more.
It was 8,000 kilograms cubed by...
Well, who cares? It's good enough.
Anyway.
So,
too much
about a 10-foot radius of this, okay? It's about a 10-foot diameter of this substance crashing into the Earth's surface. Sedimentary rock.
Dirt.
Would create a crater about 400 feet wide. And what was it, 80 foot deep? 100 foot deep? Somewhere around there.
That's bigger than a 5-story building.
So, I mean, we could literally, and it caused a 2.2 seismic activity from the spot.
On the Richter scale.
So, that's just without a payload. I mean, if you attach a nuclear bomb to that sucker...
Whoa. Nuclear bomb? What are we doing here?
I'm just saying.
We don't use nukes, remember?
I don't care.
Defense.
Well, so is this.
No, see, if they launch a nuke, we launch a nuke. It's the standoff we have with the world. Because if everybody launches nukes, we're all dead.
No, doesn't mean we're all dead.
Well, I know.
Just the smart ones.
Because if you think about it, Japan's still here, and we drop 2 nukes on them. It doesn't take hundreds of years.
Well, here's the thing. The problem, though, with that is if we drop enough nukes, it becomes a nuclear winter.
Okay.
And
so what is the minimum amount of nukes you need to make a nuclear winter?
Well, it ain't how much minimum you need, it's how much would go up into the atmosphere. So, if we dropped...
So it's worse to, usually they launch them, they explode them in the atmosphere for EMP purposes usually.
Well, see, and that's a little different, though.
Well, I know, but let's say...
That's a little better than dropping it on land where you destroy things and cause even more stuff to go up into the atmosphere. Yeah. Well, no, it's how much particles are in the atmosphere. Because if you get too many particles in the atmosphere, then the sun is blocked, which does not cause the Earth to heat, which causes a nuclear winter. You understand? If you devastate a whole bunch of places at the same time, all this debris will go up in the atmosphere and cause a nuclear winter.
Right.
So that's why we don't want to chug out all our nuclear at once. Because one at a time would be okay over a period of time. That's why they were having problems over in where the volcano was going off and they couldn't fly the planes. Because the jet engines would clog up with the ash in the air.
That's no good.
Yeah, same difference. The degrees around that area went down because of no sunlight being able to come through from the ash. So that would happen globally if we did a global nuclear attack.
Which probably wouldn't happen, but it wouldn't be globally. It would probably be specifically located in spots.
See, no, I believe it would be globally.
You think so?
Well, yeah, I mean, think about it this way. If, let's say, Korea, since we are at standoff with them right now, say, for example, North Korea decides to bomb America. Well, America has allies. No, they aren't going to attack, but we're going to have a counter-strike. Okay.
Right.
North Korea's going to have to bomb a whole bunch of cities before we stop bombing them. And would it be done bombing them before they're done bombing us? You know.
But not only do they have to bomb the United States, they have to bomb all the other allied countries.
Well, see, and that's the thing. They don't have to bomb the other allied countries.
Sure they would. Otherwise they would attack.
Your point? If they attacked, let's say they got 7 missiles out. Let's say they got 10 missiles out to attack us.
Right.
Okay?
Yeah.
So, international missiles take a while to travel. That's why they're building these things, basically.
ICBMs.
Yes.
Intercontinental ballistic missiles.
So these things would travel quite a ways. Okay? But it takes time to get there. I'm sure it takes at least...
Well, they probably don't have this kind of technology.
Well, yes, they do.
As in, no, the hypersonic...
Oh, no. But they do have a missile, they do have a torpedo that will go from their shore to California.
Didn't they call it a submarine?
It's a torpedo. It's a self-guiding torpedo. So, no man, no nothing.
Okay.
So, here's the thing. They could easily sit off our shore and hit us.
Right.
But we would devastate North Korea before they devastated America. There's way more places they have to hit in America to disable us than...
Yeah, because
they're smaller.
Tiny little country.
I mean, they're probably the size of Florida, maybe.
Well, it's more than that.
I'm just giving a...
Right.
So we could devastate them with 5, 7, 8 nuclear missiles compared to their 10 nuclear missiles to try disabling us.
Yeah.
But 20 nuclear missiles would probably cause enough particles in the air to lower our, degrees of coolness.
You mean warmness?
Yes.
Okay. Right.
But then again, it would block out the sun, so plants, animals would start slowly dying off.
And that's a chain reaction with the whole world.
Yep. Because now you got animals dying off, which could help out because methane becomes a global warming effect. So other places could easily grow food, but anywhere that was actually devastated would probably not grow very well for a while. Then the wind patterns would change, the particles would move all over the Earth. I ain't a meteorologist, I don't know how much, but it'd take quite a lot to do it. But I don't see nuclear winter anywhere in our future.
Probably, yeah. I don't think so.
Unless...
It's now information war now.
Yes, it is. Actually, it's quite an information war now. So anyway, Trace, back to hypersonic...
super fast jets.
Yeah. So, these things are extremely fast. They're using... what rockets?
Fast ones.
The Minotaur what?
Well, it's called the Falcon HTV-2.
Okay.
Somewhere in there it was called the Minotaur 4 rocket.
Well, that's the rockets they're using for it.
Okay, so the craft is called the Falcon.
Yeah.
And
So
the jets are called the Minotaurs.
yeah, you can look up the Minotaurs.
It was cool.
Right there. Minotaur 4E rocket.
Yeah, that's the one.
So, this is a family series of rockets.
Ooh.
It's a solid fuel rocket. Peacekeeper International Ballistic Missiles. They're built by Orbital Science Corporation.
Peacekeeper missile. I always like that one.
Yeah. So, I think they did say they're using the 4, right? Is it more capable?
Yeah, that was a Minotaur 4, yeah.
2 more versions also under the
They have Minotaur 5s now.
Ooh. Okay, let's look at Minotaur 5 here. Minotaur
Scroll
5. 5-stage version has been
conceptualized. So it's not, they're not.
okay, so 4-stage.
4 is the highest one.
Solid fuel mortars for whatever.
Where are you reading from?
Right there. 4.
Oh, where were you reading? I didn't see where you were at.
Right there.
Oh.
Solid state motors from decommissioned peacekeepers, whatever. So they have what, 4 stages? The SR-118 first stage, SR-19 second stage, SR-120 third stage, and Orion-38 fourth stage. Oops. Payload of 1,735 kilograms to a 180 kilometer, 28.5 degree orbital from Cape Canaveral. So here's another thing. I'm just wondering if. Anyways, never mind. I'm just thinking out to myself. So these, it's a 4-stage rocket.
Okay.
And there's 4 of them, was there not?
It looked like it. If that video was going to be.
Yeah. Yeah, there's a page with a video. But I believe there was 4 rockets.
A computer-generated video showing
what's supposed to have done. It failed.
Right.
The initial test has failed.
Well,
after 9 minutes of flight. They lost
contact.
Well, that's failure, ain't it?
It is, but maybe just the radio was burned up or something.
Okay, so they lost premature contact with it.
Right.
And it's supposed to, if something happens, fall in the ocean. We don't know what happened to it exactly.
Right.
They don't either.
They say they don't know what happened to it, but I'm sure they hit their target.
I'm sure.
And we don't know, maybe it was no.
Well, I mean, right now, think about this, okay? You're looking at the government. They just canceled the NASA project. So no more rockets into space. But they still shoot rockets up to test. Crazy? No. So.
Well, it's not crazy. Well, I always thought it was
crazy.
weird that they shut down NASA, but they still haven't finished the space station yet completely.
Well, other countries go up.
All right, but
and the space station was never ours.
Well, it was a joint effort.
It's a joint effort between Russia and America, was it not?
Well, at least those two. There might be some here.
Well, I'm sure there might be. But, so, we're basically saying, hey, Russia, go ahead. We have other things we're doing.
They probably have a program up there in that space station that they're launching these things from.
Well, maybe. I mean, if you think about it, okay, we look at technology as being behind. So, think about this, for example. What you read in the newspaper has already been tested and designed. Now they're just coming out with it to the public.
Right.
These things have probably already been tested without our knowledge, without anyone knowing about it. I mean, if you want to go the conspiracy theory way, we could literally say that the governments have been hiding things from the people for years.
It's not specifically because hiding it from us civilians, but they don't want to Because those are secret projects, so they don't want the enemy.
Yes, I understand. But here's the thing, okay? You're to make a project. Let's say I'm making a weapon to destroy countries in an hour, okay? So if you could position satellites around the world,
right?
Because we do that just because we say they're satellites for certain reasons, and they've been
satellites.
They've been, well, I mean, seriously, I mean, how big of a satellite do you need to launch one of these things? I'm assuming not that big.
Well, you think it just needs something to hold, just to hold it while it launches itself? Or
Probably.
something to help it launch?
I think it just needs something to hold it while it launches. Right. And who says this whole thing is, the whole satellite is not part of it?
That's another thing I was just thinking of.
Part of the satellite just comes up and goes shooting down.
Right. And it breaks up in the atmosphere.
Yeah. I mean, it is not that hard to design one of these.
And they just say, well, our satellite had a failure in it.
Yeah, and and it could be true. I mean, how many satellites are up in there right now? Thousands, millions.
No, not millions.
There's hundreds of thousands up there, I'm sure.
Right, but not millions.
Okay, how do you know?
There's probably not a million up there, so that'd be too much. It seems too many. Don't believe it.
Alright. Fine, you do it. I guess you want to go to the other.
Blah, 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 blah. I saw another thing on there. How many man-made satellites are over Earth?
That might be good. So, 220,000, 220, 2,200 tons.
2,200 tons.
2,200 tons of man-made junk in the environment near the Earth.
25,000 man-made objects.
8,681 currently in orbit, and over 16,000 in state of decay.
The ones that we're not using, they're just floating around.
Yeah. So look at that.
Not millions.
Who cares?
I knew
Good
it
enough.
wasn't.
So still, we got 16,000 objects in space that could potentially be...
Right. They might not be in decay.
You know what? There's another thought. We could use a strong electromagnetic field to pull down these things.
Why?
Why not?
I mean...
I'm talking about theoretically.
I mean, are you just saying just to get rid of them?
Well, no, because they're going to burn up the atmosphere. They're going to hit.
They could burn up.
Not all of it.
Well,
that's why we don't drop them down.
That would make sense. Why don't we just push them out into space?
Well, why not collect them and bring them back down and recycle them?
Oh, we could do that too.
So any which ways...
We are thinking green here on the Sci-Cast.
So any which ways, think about this. If you use a strong enough electromagnetic pulse to pull them out of the orbit in a certain trajectory, you could devastate towns.
Oh, I see what you're getting at here. Using it for military purposes.
Yeah, I mean, just theoretically, I really wasn't thinking about it until now. You use a strong electromagnetic pulse.
A tractor beam?
Well,
that's
basically.
That's what it is.
But, I mean, still, you could get a strong electromagnetic pulse radiated at this thing, so its trajectory changes just slightly to cause it to come into out of Earth's declining orbit it already has, into a more declining orbit. And it can be calculated, I'm sure it could be calculated, to see where it's going to fall doing this. So you could pull it out at the right time.
Right.
So it falls exactly where you want it, or approximately where you want it.
Right.
So imagine, you got 16,000 things, 1,000 satellites falling down on America. Across America's soil.
Is that what you want?
No, I'm just saying, could happen.
Not at the same time, though. You wouldn't be able to track all those at the same time.
Why?
Because they're all orbiting different spots in the
But what I'm saying, I'm sure there's clusters of junk together.
I'm sure.
You got 16,000 pieces of junk up in the atmosphere.
Yeah.
You know, I'm sure you can find the biggest cluster of junk and pull it down on top of someone.
Probably could.
You know, I'm just saying.
So we better do it first before somebody else does.
Well, I think we should clean it up so it doesn't do it itself. So
It probably is right now.
Well,
Random,
there is random ones. So that was just that. So DARPA, if you're listening, go ahead, use my idea. Oh, it's just an accident. So that would be cool though. So how do we do this now?
Okay, we got blah blah blah. That. Can we talk about how fast it goes? We kind of do, but not really. Mach 20.
Well, yeah, it's Mach 20, 13,000 miles per hour, which translates to about 216 miles per minute to about 3.6 miles per second.
Yeah, that's exactly right. How'd you know?
Approximately. I mean, there's other numbers, and I just ain't going into decimal points.
Yeah.
So, I mean, 216 miles a minute, that's
pretty good.
Well, it's 400 something from my mom's house up north to Iowa, Council Bluffs, where I used to live. It's 416 miles. So we can get there in 2 minutes.
Every time we come up with excuses and not being able to go.
Yeah, no.
We were like, sorry, I can't make it. It's too long of a trip.
The only problem with that going Mach 20 would probably rip your body to shreds.
That's part two. We should probably get into that.
Yeah, it's non-manned flight.
The G-forces.
Yeah, I mean Mach 6. I guess we should look up how many G-forces. But I mean,
we can use this for delivery.
Delivery of what?
Stuff.
Well, you could, but I mean, you'd have to slow it down when it gets there.
Well, sure.
I mean, unless you had like a catching system and.
Yeah, you shoot on a wire.
So
just the right trajectory.
G-force of Mach. How do you spell Mach?
A-C-H.
6. Let's do 20. So the G-force of Mach 20.
Oh, that hypersonic plane is a Lockheed.
Lockheed, what's that?
That's a company.
Oh.
They make planes. Lockheed.
So, okay, I hate doing that.
Yeah,
That's Facebook.
Okay, that was an ad.
Oh, so help me out here.
Let's just do this. Control F, find.
They don't, guys. Yeah, help me out here. G-force community.
Here, just go back. Yeah.
Yeah, you figure it out. But I mean, the G-force of this one.
Yeah, that should work. Yeah, that probably work.
So.
Where's the form? We don't want form.
That's not what we want. That's G-force. Speed of rotation, G-force, speed of rotation.
Here, I go back. I'm going to type in something else.
The G-force caused by Mach 20.
Go to the Wikipedia page. They have the answer for everything.
The Wikipedia, no. Speed and G-force, supersonic flying military fighters. I want to open that too.
Click on
I don't want to. So anyway,
come on, do it now.
So, hypersonic, m divided by 5.
No, it's
Speed.
that's m greater than 5.
Okay, m
So
greater than 5.
Anything greater than Mach 5 is hypersonic.
Okay. So, no, because...
It's a greater... Yeah, hypersonic.
Okay,
Mach
whatever.
5.
Sound barrier is transonic. Mach
Is Mach
equals
1.
1.
Yeah.
So, any which ways, there we go. G-force, relative.
Let's go down to the contents. What do we got here?
Units of measurement. Acceleration, force. Turns forces. Force. G-force.
Surely it's difficult to find. I don't understand.
Yeah, I know. So here,
here's human tolerance of G-force.
Well, still, I mean, a constant 60 grams per minute, however, may be deadly.
16 G.
So I'm guessing it depends on what's going on because death, if G-forces are not quickly reduced, death can occur.
You don't want that.
No. Here we go. Examples of G-force. Space gun with a barrel length of 1 kilometer and muzzle velocity of 6 kilometers.
1800 G. Oh my God, it's gonna kill you.
So I mean, Formula 1 car is 5 to 6 Gs.
How about the mean acceleration of a proton in a Large Hadron Collider? 190 million
So I mean,
Gs.
still, I mean, death and serious injury likely at 50 Gs. Typical max turn in a aerobatic plane of fighter jet, 9 to 12 Gs. Maximum for humans on a rocket sled, 46.2 Gs. So, you know, I mean, re-entry for a space shuttle is 3 G. So,
well, then we got the acceleration from a Wakefield plasma accelerator is 8.9 to the
10th power.
10 to the 20th power.
Oh, here. Is damp mass and then the spring. God. Why is it so hard to figure out how much a G-force is?
I think I'm typing into Google around. Let's go back to Google.
There you go.
Let's see. 20 G's.
No, you can't do 20 Gs. Do how much G-force does a Mach?
Oh, right, it was Mach 20.
Yeah. How much does Mach 20
Yeah, backwards.
equals?
Equals.
How many Gs?
That doesn't give us anything.
Mach 10 force gauge, right there. Oops. Damn it, I hate that.
It's because of the new version of Firefox. They switched the two around.
That's not what we want. So, Mach 10 force gauge, Mach 10...
Maybe we should skip this. Anyways, it'd probably kill you.
There we go. I might have had. Anyways, yeah, I'd say probably devastate you. So, I'm reading, so sorry. Could only hand you a force vehicle, try to win it. So, yeah. Well, I don't know. That's a form which I ain't ever really.
Anyway, we probably wouldn't be able to take this journey at this speed.
Probably not. I mean,
At least not yet.
yeah. I mean, if we got inertial dampers. What?
Star Trek talk there. Huh?
Well, that's in other ones too.
Like, well, I've never heard.
Well, I mean, what do you mean? Like in
I've never heard a reference. No.
Stargate has it.
I never watched that show. Well, I like the movie.
Stargate was a good series. You should watch
Which
it.
one, the original or the new ones?
You know, I actually watched all of them, so literally I've watched every single one.
Yeah.
Yeah, Atlantis.
Even the straight to DVD movies that came out?
Yeah. They actually have some great concepts in there. Seriously. You should watch it. I bet you'd love it.
They streaming on Netflix?
Yeah. That's how I watched them all. No, they talk about inertial dampers in there too. Because of the fact that when you're traveling...
Maybe we should tell the viewers what inertial dampening is.
Well, you know what inertia is. Inertia is when objects in motion tend to stay in motion until acted upon by another force. So that means when you're traveling at 13,000 miles per hour, until you're acted upon by another force, you keep on going. That's your inertia. So inertia and dampers literally stop you from feeling the effects. If a rocket's taking off at 700 miles an hour, you're being flown back. Just like if you're in a car and you speed real fast, you get thrown back into the seat. Inertia and dampers will stop that from happening. Yeah. So you can accelerate without feeling it or having the effects pushed upon you.
Is this some kind of super science kind of thing?
Yeah, it would be probably a quantum mechanics science.
Yeah.
Because it does deal with the forces of gravity and inertia and the general relativities and stuff like that.
Oh, that's cool stuff.
Yeah. What would they do in hopefully at least the next podcast maybe?
One of the next two.
So, basically, that's what inertia and damper is. There's other things that could go along with that. Seatbelts wouldn't help you because the seatbelt would crush you.
You think so?
Yeah. Well, that's the theory. You're having the seatbelt up around you, so it's getting pushed in just as much as you're getting pushed back.
I see what you're saying.
So, if anything is in front of you, your clothes would feel extremely heavy pressing against you. That's why you would die, because the G-forces basically crush you and limit the flow of blood through you by crushing them to the sides of your veins.
Not good stuff.
No. Literally it can cause you to go blind temporarily, probably even permanently.
Depending on duration, I'm guessing.
Well, yeah, I'm sure. Because the blood capillaries in your eyes will literally cease to stop. I mean, well, not cease to stop, but will stop.
Double negative.
Would cease to continue because of the force that are being pushed upon them. So with inertia and dampers, which kind of seems far-fetched to me.
Right. I mean, it's a tough concept to wrap your head around.
Yeah, I don't...
But it would almost be necessary if you were going to do...
It would be necessary unless somehow you just removed yourself from the equation somehow.
Quantum mechanics.
Well, yeah, I mean...
Just jump in here.
Well, I mean, seriously, it'd be the fact that the only way we're going to do space travel is if we slowly accelerate to the speeds we want. Because once you reach the speed, the only problem you're going to have is slowing down.
Right, and it's just the same problem but in reverse.
Yeah, exactly. You got inertia, which causes you to react to the things around you. So if you slow down slowly, you'd be okay.
Momentum.
It's the sudden stop at the end that kills you.
Who put that stop sign there?
So, I mean, yeah, that would be the biggest problem.
Yeah.
But now, let's use some of the other things that are using the different types of flight. You know, they instantly stop.
You mean like...
Because they have inertia and dampers.
You like Star
well,
Trek
like
things?
Star Trek, going to warp 9, then I would say just stop into impulse.
Right.
No, you don't see them all go whoosh up to the view screen and crash into it.
Right.
Because of the inertia and dampers.
I think that's just a writer's trick to get over that kind of...
Probably.
What do they call this? It would be a... Plot hole, I guess.
Yeah, but again, then there's the fact that warp fields literally create a bubble around your ship, which destroys space in front and creates new space in back, which is what pushes you.
So like air pressure, right?
Kind of, yeah. And you literally, that's why you don't want to go through planets with the warp field, because it would destroy the planets and create new space behind you. What? That's why you have to plot courses, because anything in your path that would meet your warp field would be disintegrated.
Yeah, that's probably not something.
I'm just saying, and that's basically how you're getting over the fact that you can push a ship past the speed of light, because literally you're destroying the space in front of you, creating new space behind you. So you really ain't moving the ship, you're just moving the space that you're in.
That's a cool concept.
Where if you take that, then there's Star Wars, which does what? They have hyperspace.
Warp speed. Very
ludicrous speed.
Yeah. Well, that was Spaceballs.
Plaid.
I think they call it warp speed.
Is it warp?
Yeah.
So, okay, then they're probably doing the same. But like in Stargate, they literally cut a hole through the fabric of space into hyperspace.
Right.
And drove through hyperspace at regular speeds.
Like wormholes you're talking about?
Well, no, it's hyperspace. It's literally just to space where the effects of gravity, inertia, and all that are not the same. Kind of.
Okay.
It's kind of like a wormhole, which will let you travel really, really fast, but your ship doesn't move fast.
I thought the wormhole means
wormhole is
you didn't have to go
instantaneously.
fast, but it was a shorter distance to travel
Yes.
great distances.
Wormholes are different, though. Wormhole is literally, it opens a point from A to B,
right? And you just fly through.
and you just fly through the hole.
Right.
I mean, it doesn't matter where you are. It just basically folds the space, and you go through the hole.
Right.
Where hyper jump, you jump through a gate between them, which connects the 2 points, but it's like instead of having this space right here, you're folding this space and making a gate between them.
Right.
You know, so they're closer, but they aren't touching.
Right. Gotcha.
You get what I'm saying? Yeah. You're basically opening a straight line to them instead of having to fly through space, and you just open that straight line straight to them.
Good stuff.
So again, we should do one on Stargate.
We should.
Yeah, you should watch it and get the concepts. They have a lot of concepts you would like.
Okay.
Especially.
Can we start at the beginning? Is that where they have the original science behind it?
Yeah, kind of. I mean, through the whole series, that you get to learn more and more. Okay. But basically, you got these gates, which that's what they're called, Stargates, with symbols on them, and these symbols correlate with patterns throughout the known universes. Well, and anywhere else that has a gate has the same constellation map.
Right.
You got the point of origin and the 7 other ones that depict where they are in space. Okay? You understand?
I mean, I saw the movie.
Okay, so you understand the 6 plus the 7th one. The 7th one is the origination, and the other 6 are the destination. So you got the 6 that points out where the planet you're going to is, and then you got the 1 that points where you are. Okay?
Right.
So this literally opens a micro wormhole.
Right, yeah, because that's what they try. I remember the
yeah. Now, the thing I didn't get until later on in the theories, in the series, is that you could only go one way.
What do you mean?
You can only go one way. Like if you open a gate from Earth to another place, they can't walk through.
Oh, okay.
You can only walk through towards the other place. So once you're in, you have to dial back to get back. I didn't get that concept until later
Well,
on.
they kind of mentioned that in the movie, where you have to
Yeah.
But so you're saying even though you
matter only travels one way through it.
Well, right, but what I'm trying to say.
But you can send radio waves through it.
Well, but what I'm trying to say is that you put the gate, you open the gate here on Earth, and you go to the other planet, right?
Yeah.
When it opens the gate here, the exit's here, right? You can't walk through the exit.
No. And if you're in the event horizon when it's created, you get destroyed. Yeah.
So you probably could I guess you can you really calculate something like that?
I'm assuming you could. I mean, it would be, but it'd be so much energy to even create that. It'd be unbelievable.
Yeah.
To create a stable wormhole between 2 points in space. Yeah.
Yeah.
So, anyways, that's how we
need to find a new power source. That's all we need.
Well, we do have power sources that we don't even think about on Earth.
Like.
Well, I mean, for one, heat. We don't really use geothermal energy much.
Geothermal is always a big one.
Well, yeah, I mean, we got a planet that is losing its heat no matter what. I mean, look at Yellowstone. I don't want to deface, national parks, but Yellowstone, it's a boiling hotbed of potential energy that we could tap and relieve some of the pressure by tapping it,
right.
Which would not, if it exploded, would not destroy.
It wouldn't become a super volcano.
Yeah.
Everybody's freaking out about.
Well, I mean, you send 5 tubes into it to run some of the heat off, and it would slowly cool down.
And we could tap that heat.
And we could tap that heat for potential energy.
Right.
I mean, you don't need to be right in the park and have a big, huge plant.
Yeah.
You could literally run a conduit to it.
Underneath the ground?
Underneath the ground. I mean, it's a big volcano. You don't have to be, I'm sure you can be like 20 miles away and still get the heat from it.
Probably could.
So, I mean, potentially, we could have 5 plants surrounding this, creating gigas.
Seamlessly unlimited, in theory.
In theory, well, no, it's not unlimited, because sooner or later it's cool down enough to...
Right, but it wouldn't cool down for a while.
Well, yeah, I mean, but still, you got potential energy that we're wasting right now. I mean, now you're talking about all the... I believe Walmart was planning on this, but creating solar panels in their parking lots. So the whole parking lot is basically one big solar panel.
You drive on?
Yeah. I mean, all it is reinforced acrylic glass. I mean, it would have to be properly cleaned every day.
Mechanical problem.
No, I mean, but still. Now, another thing is some parking lots you could actually put in...
Would that replace the cement, concrete, whatever they use are? So you don't have to worry about it.
But you're using acrylic.
The heat wastage coming off it.
Well, no. And another thing you could do with that is you could use some of them for solar heating, some of them for the electricity. Have carports where you could pay to plug your car in while you're at
that is a good idea.
Walmart. Or Target. Yes, Target.
Well, if Walmart does it, Target will do it.
Well, I know. Then, another place is most of the roofs of these places are not being used.
Yeah.
Okay. Another untappable source.
Huge,
yeah. I mean, don't get me wrong, it costs thousands of dollars to retrofit all this, but the potential savings they could put back into the world is enormous. I mean,
savings to them.
Well, yeah, but I'm just saying, Target donates how much? Millions. I mean, if they said, hey, we're making this much more energy, let's give it away for free, and then they could go, households that are not being able to have electricity during the winter or heat during the winter, let's substitute what we're making and put it back into the world. Just a thought,
Right.
We really got on a tangent here.
We did.
But that's okay. And there's other potentials we could do. if you don't want to put solar panels, put what is it called? It's not geothermal. It's kinetic.
That's possible. You could also use
it's the bending of stuff, of the metal, of the material. So when cars driving on the parking lot, it would bend it slightly, causing for energy being produced. Because in one state they're doing a sidewalk that has these kinetic generators. So as you're walking along the sidewalk, you're literally powering the streets.
You had those New York streets.
Any streets.
I'm just saying, because they got thousands of people there.
Yeah, but I mean, if our sidewalks all had that.
Right, but we have a lot of sidewalks.
I understand that. But what I'm getting at, we got walking paths. If we put it on the walking paths, how much energy that could generate? It's wasted energy. I mean, don't get me wrong, it might not account for much, but it's being wasted. And Brian said, hurt me for going on to this tangent, ain't he?
Yeah, he probably will. We should probably wrap it up. We're getting pretty long here.
How long?
At least 40 minutes at least.
So, get back to our topic here. Hyperspace flight, not for humans.
Hypersonic.
Well, hyper anything.
Hyperspace is something totally different.
Okay, hypersonic flight is not for humans.
Yes.
Well, okay.
Dampeners.
For at this moment, it would crush you.
Like a pancake.
Other things, don't want to be hit by it either when it crashes on top of you.
Well, you don't want to be hit by anything crashing. Even at 10 miles an hour, that'll still hurt you.
It could. So this is an attempt by the government to have world domination, and I'd like them to stop it. No.
Well, at least we're doing it, right?
Yeah. I mean, being able to hit any country, any state in an hour or less would be a great achievement, because now people would fear us even more. And hate us even hate us even more, probably. Because we're arrogant, stubborn, and...
Oh, come on, who isn't?
Well, see, and that's the thing I don't understand. See, other countries find us arrogant, stubborn, whatever else you guys find us. Because I'm sure you do. Because, I find some other countries arrogant, stubborn, and everything else, too.
Like which ones?
I ain't saying which ones, because they come attack me.
Well, stop watching our podcast.
Well, it ain't that I find the country arrogant and stubborn. I find people from that country arrogant and stupid.
But the people make up the country.
Well, yeah, but you can't use all the people. I mean, the sum of the state is different than individuals. I mean, it's a totally different thing. Because some of the stuff is okay, but you got individuals that think one way, and only one way. I mean, I'll use examples, hillbillies from here, USA. Hillbillies usually tend to think one way and one way only. Their way or the highway.
Right.
You don't do it their way, we don't care about you. And same with people in business. They think one way. It's our way, and that's it. I ain't to not make a profit off it, I don't want it. You get what I'm saying? It's the same with countries. The individual is what's making up the country.
Right.
But the individuals also has different... I don't know how to explain it. You know what I'm trying to say?
I know what you're trying to say, but it's difficult to equate. We'll just say not everybody in the country are the same.
Yes, you're right. That's exactly what I'm trying to say. Not everyone in the country is exactly the same.
Not everybody in America is arrogant.
Yeah, I mean, don't get me wrong. Most of us act arrogant sometimes, but we really...
Isn't it human nature, you know?
Well, I believe it is. We should do one on psychology, too.
Psychoscience.
Psychoscience, yeah. Could have my friend Mike. He's really big into that.
Yeah.
He's huge into cycling.
He's a cycler?
No, but he's into it. So, as for now, let's sign off, because we're really far on a tangent.
This ends episode 20, okay? Remember that 20. We hit 20 episodes here on the Sci-Cast.
So next episodes will either be quantum mechanics or cryogenics.
Which means we're gonna talk your brain off about
freezing your brain.
Yeah, freezing your brain right off. Or talking your head right off with another quantum talk.
Yeah, we're gonna try simplifying that a little bit though. I really don't want to go into mathematical equations and that. So
neither do I. It's not fun to talk about that kind of
stuff. So we're kind of tone that down a little bit. And cool tip: anyone that has Universal Sandbox, you can make it 3D.
Without a 3D TV.
Yeah, without a 3D TV.
Well, you need some 3D glasses.
Well, you can make 3D glasses.
Well, yeah.
Color one part of your glasses red and the other one green. Works the same.
Use an old pair of glasses.
Yeah, just go buy the $1.50 pair at Target or whatever.
Yeah.
Color them. Put them on.
So should we get some shout-outs too to people we know?
Two
people. Shout-outs.
Well, Judy's probably will be watching.
Hey, Judy.
Sean.
Big money.
Big money. Big money. I'm sure other people will start watching now, since that's the only way that it'd be able to see.
Should we mention Brian? I guess we have. He always says he feels he's being neglected now that he's got kids at home.
Well, see, Brian keeps on telling me that I keep on scheduling the days that he can't make it, but he can never make it. So that's his
schedule around the days you can make it. That's the thing, because I can do it anytime.
Well, no, because he told me, he goes, you schedule it around the days I can't make it. I go, okay, what days can you make it? He goes, well, none until September. So
you're both right.
So I mean, literally, I mean, if he could be here, he'd be here.
Yeah.
I do like him here. He's a yin to my yang.
That's beautiful.
So, I guess to all our viewers, I wanted to shout out to our viewers.
Shout them out.
Well, I don't know them all, so, but shout out to all of them.
Yeah.
So,
check out the website, www.thescicast.com, or Facebook at the Sci-Cast.com.
Well, the Sci-Cast.
On Facebook.
It's just the Sci-Cast.
Okay, we're on YouTube at the Sci-Cast Doctor, all one word.
Or hit us up at Dr. J at thescicast.com, or
emails.
Heyman at thescicast.com, or the special guest at thescicast.com would be Brian. And I'm thinking that I'm going to start putting day by day of my story up on the Sci-Cast.
Have you been continuing to read?
Yeah.
Did you read my...
Yeah, I read. Brian read your revision. And he said, instead of some grammatical errors, so I kind of laughed.
Wait. What did he say about mine?
He said some errors about yours.
Well, there's probably some I missed. That's probably why.
Well, I didn't revise it, so.
So what am I doing?
I don't know.
I'm here peer reviewing your book, and you're not even looking at it and making changes.
Who, me?
Yeah.
Of course I'm not.
Well, why am I peer reviewing it then?
Because you're the one that's supposed to be making the grammar. It says, grammar notwithstanding, it's a very good start. I actually have some interest in finding out what loser is going to do next after he's done.
I'm sure you signed on mine?
Yeah. I sent him your revised.
Okay.
So, he thinks your grammar is quite bad anyways.
No, I'll have to talk to him about it, because mine's not.
I sent him your grammar list. So.
You sure?
Yes.
Okay.
I'll recheck, but yes, I'm pretty sure I sent him yours.
I mean, I tried as hard as I could to redo the grammar.
Well, maybe because the way I had it was better grammar.
I don't think so. Well, some things were fine by themselves.
It's just when you start changing my kind of grammar, it doesn't fit into other kind of grammar. You get what I'm saying?
Two people's writing styles.
Yeah. Oh, anyway, Trace.
He's writing a book anyways.
Yeah, I'm writing a book, which I think I might just put 1 page up a day, 1 page a week, maybe.
Okay.
So, on the Sci-Cast, so you can start reading it. No. So, I'm Heyman.
This is Dr. J.
And we're signing off.
This is the end of the podcast.